Hello and welcome back to Python Deep Learning for Beginners. We're starting a new section today, and we're finally building on the concepts that we've learned to dive into deep neural networks. In this section, we're going to take a look at 4 different topics building on top of one another. We're going to first look at feedforward networks, and then we'll look at backpropagation, and then we're looking at neural networks from scratch. How can we build a neural network from scratch using Keras? And then we deep dive into the problem of overfitting and regularization. Feedforward networks. In this video, we're going to take a look at feedforward networks. We're going to do this in 3 steps. We're going to go from perceptrons into feedforward networks. We're going to then look at what's a single layer perceptron network and how can we go from here to multi-layer feedforward networks. Going from perceptrons to feedforward networks. So we've all seen a diagrammatic representation of a feedforward network. It's very simple. It looks like this on screen. And all it is we have here one hidden layer of 4 neurons, an input layer of 3 features, and an output layer of 2 classes. All the arrows here, the black arrows, signify the connections between inputs, hidden layers, and outputs. So the relationship between a perceptron and a hidden layer is each of these circles in the hidden layer, i.e. the blue circles, are actually perceptrons. As we know from before, a perceptron is a combination of a linear model and a non-linearity function. So the linear model takes 3 inputs and correspondingly has 3 weights, right? Because there are 3 input features, 3 circles. The fact that we have 4 hidden perceptrons means that we have 4 flavors of weights, each trying to learn a different feature or different aspect of the inputs. By randomly initializing all of these weights, as we start the training, we can allow each hidden perceptron to learn a different set of weights for its linear model. And we know that there's no weights or any sort of parameters in the nonlinear function in the perceptron. So when we talk about the weights of the perceptron or the weights of a neuron, it usually means that we're talking about the weights that are inputted into the dot product. So here, because we have 4 hidden neurons and 3 input features, each hidden neuron has a weight vector of 3 weights, and we have 4 sets of these 3 weights. And by trying to learn 4 different weights over 4 different perceptrons, we hope to extract 4 different aspects of the input so that it allows us to cover all the bases from the inputs. The output of the hidden neurons, i.e. the 1s or 0s, i.e. whether they fire, goes into the outputs. And then the output is again a linear combination of weights, this time 4 weights because there are 4 hidden neurons, and a nonlinear function. After this, whether each one fires creates 4 different outputs possible in the output layer. The other name for this, for one hidden layer, is a single layer perceptron network. So naturally, to go from single layer to multi-layer, we just need to insert more hidden layers in the middle. Here we've extended our input layer into a first hidden layer like before. So we can see that with 3 input neurons, 4 hidden layers in the first layer. Instead, we create another hidden layer of 2 hidden neurons before we go into the output layer. So by adding more and more neurons in the middle, it means that we have a chance to explore more aspects of the data and then aggregate these aspects and learn how we should weigh these aspects in the second hidden layer. So one of the ways we can see this is in the first layer, we take the 3 input features and we compute 4 different aspects of the inputs. These 4 aspects are then weighted and combined at the second hidden layer into 2 master aspects. These 2 master aspects then affect how we output the 2 different classes in this feedforward network. And that's all there is to it. It's really simple. We're stacking what is the basic building block, a perceptron, into a single layer perceptron network. We then can stack these single layers into multiple hidden layers, and that gives us a feedforward network. And that's how we go from perceptrons to feedforward networks.